In this video, we're going to look at a problem type called optimization. Optimization problems are word problems where you're trying to either maximize or minimize something. There's a variety of different word problems you could be given on the AP exam that involved optimization. Because of this variety in different question types and the difficulty of each one, we're going to spend a few days looking at optimization. In this video, I'll give you general steps on how to tackle an optimization problem. And then the next few videos will just be examples of how to solve specific optimization problems. The standard that the College Board uses for optimization is FUN-4.B.1, and that says the derivative can be used to solve optimization problems. That is, finding a minimum or maximum value of a function on a given interval. Out of anything we've done this semester, I'd probably say this very specific problem type has the most application out of anything else that we've done. If you're interested in going into a field like data analytics or data science, if you are good with optimization problems, then you can really earn the big bucks. These types of problems are solved by computers, but the process of setting them up really is an art form that computers just cannot master. Because of that, data scientists who are experts at optimization problems, they earn really good money and they are in high demand. The optimization problems we'll look at in this class are very simple compared to the types of problems a data scientist would see in his or her everyday work, but the basics are the same. Let's begin with a few definitions. The function that we're trying to find the max or min of, this is what's called the objective function. Often in these problems, you're going to have several different functions or several different equations floating around. So it's important to know which function is which. Whichever one you're trying to optimize, whichever one that you're asked to find the maximum value or the minimum value of, that's the objective function. That's your main function. And then often there's some sort of constraint that you're given. This is a secondary function that you are going to use to rewrite the objective function. So the standard for the College Board says that we have to find a minimum or a maximum value. In order to find the maximum or minimum value, all you have to do is use the first or the second derivative test. Whichever test you use is up to you. Typically for polynomial equations, the second derivative test is going to be faster. Just remember that if you do the second derivative test, you might find that it's inconclusive and you have to fall back and try the first derivative test. If you have a polynomial function, then the second derivative test will always give you an answer. And then the College Board standard, when they mention the function that you're trying to maximize or minimize over an interval, that is the objective function that they're talking about. Now, let's look at some general steps on how to solve an optimization problem. First up is you want to just read through the problem, extract any information that you have from the question. You might have to define some variables. It could help to draw a diagram in order to fully understand the question that you're given. If you're not given the constraint function, oftentimes drawing the diagram can help you figure out what the constraints actually are. Step 2 is we need to determine what equations you're optimizing. This is going to be the objective function. Sometimes the objective function that we have is multivariate. That means it has more than one independent variable. In this class, we don't know how to maximize or minimize a multivariate equation. So in order to maximize or minimize this function, you have to be able to rewrite it in terms of a single variable. This is where the constraint function comes into play. So step 3 is where we actually consider the constraints. If there is a secondary equation that relates the variables together, then use that equation to substitute in for the variable in the primary equation. Step 4, this is where we actually do the optimization part. Use the first derivative test or the second derivative test on your objective function to find the independent variable where the extrema occurs. If you're doing an optimization problem on the AP exam, be sure to fully complete the first derivative test or the second derivative test to actually show that whatever critical points that you have found are actually a maximum or a minimum. If you merely find a critical point and just assume that it's going to be a max or a min without showing that it is a max or a min, then on the AP exam, you're going to lose a point. And then finally, step 5, plug the independent variable back into the objective function, or possibly into the constraint function to find the optimized value. Be sure to carefully read what the question is asking you and to provide those answers. Sometimes the critical value that was the maximum or the minimum, that's all that's needed to answer the problem. Sometimes you have to plug that value back in to actually find the maximum or the minimum y value. Or sometimes you have to plug your critical value back into the constraint function to find another dimensional value. So that's it for the steps on how to solve an optimization problem. In the next few videos, we'll look at different optimization problems and see how we apply these steps. The 2 optimization videos you're going to see today, these are a little bit easier, and then the 2 optimization videos you see tomorrow, those are a little bit more advanced.